To start off this video, this is just a reference for myself and for the people who I wanted to share this experience with. So this is my SIP project, student internship project. So in Samaras there will be words around flying, maybe subtitles. So the video is just for my friends, or if you want to comment everything, just write it down. I don't really care. So the project I have done in throughout 14 weeks. It's SIMATIC S7-400 and WinCC, handling industrial task with ease with IIOT ready. By IIOT ready, it means that industry Internet of Things ready, where later we'll go deep into it. SIMATIC S7-400 is the one of the more high-end PLC provided by Siemens, and the entire project will be done with Siemens products, and the training kit used will be provided by Fisher Technic. And we just now talked about WinCC. WinCC is one of the software provided by Siemens as well. It comes with a package. Is it? Oh, you can download it, and then you need license to actually use it, to use the software lah. And WinCC will be using for SCADA development, and for PLC programming we will be using what's it called again? SIMATIC Manager, which is step 7, right? Later we'll go through to within the project and some of the information and details of the project, and we'll go through SCADA, which is supervisory control and data acquisition. It's a kind of computer system where you can pull data from your PLC and then you can monitor it through. It's like a real-time monitoring lah. The function is provided like that. So we can take a look at. Can we switch it? No, cannot. We can take a look at the hardware first, of course. A quick look at the hardware, my workstation and everything. Later we can go through some of the operations of my Fisher Technic training kit and the usage of PLC, as well as some maybe explanation on my codes, on why I do it, on my struggles and everything. And okay, so this is my workstation practically. So the thing you are looking at right now, it's the thing you're looking at right now, it's the PLC programmable logic controller, the SIMATIC S7-400 to be exact. We'll go through it in detail later. So the thing you're looking here, this module right here, it's the power supply. This is the distributed IOs, input output ports, terminals, call it different ways. And the center one, it's actually the most expensive one. The whole thing could cost around 20,000 per set. So this is 20,000 and the other set is 20,000. So at all of it, it's around 40,000, the entire set. So the reason of we have two sets of PLC is because it's an H system. It's also called an redundancy system, where one will assume master, the other one will be in standby mode, and when some fault happen, it will switch over the control. Let's say if my master PLC has some, but this is a master button, indicates that this PLC is currently taking master of the entire H system. So if my PLC down, let's say I stop it, and then the other one you'll see it will switch over to master, which means that this one will be taking control. Just restart it for a while. Right, okay, so then this is my PC provided by my host company, of course. And after that, PLC, we have a few systems like the communication system. The purple wire, it's known as Profibus. It's Siemens issued. The green one, it's Profinet. It's a kind of industrial internet in Ethernet standard, work on LAN. And the orange cable, which is the, what do you call it, fiber optic cable, where it allows the two sets of PLC to communicate with each other. And then after that, you will see the Y-link. After, it will be connected to the PLC by Profibus. And then after the Y-link, this tree is the Y-link set. This two is Y-link and this one is Y-couple. The two PLCs will connect to each independently, and then these two will connect to Y-coupler. And after that, Y-coupler will only connected to ET200M, which is my distributed IO. Yeah, and my ET200S DP. Today we'll go through it on why the configuration and why the system configuration and structure is like that. And the last one, it's SITOP. SITOP, it's the power supply that provides power for distributed IO, and yeah, there's distributed IOs and my training kit. This training kit, it's my training kit. What the Fisher Technic. I have the manual with me, but we can go through with the operations and see. There's a Fisher Technic. It's called pneumatic process plant 224 volt, and the plant is actually, I couldn't find it on internet, like much of the information, just maybe a few videos and someone selling it, but it's really hard to find. The manuals are hard to find. I couldn't find it. So right now let's do some simulation and on how the plant works. It's still under progress. Actually, the plant is already ready with the programming and all, but now we are just doing some tuning. The host company supervisor is giving some challenges, some new tasks to modify the code to test the ability of the intern. So let's say now I reset the whole plant. I call it initialization. Okay, so I feed in my first object into the magazine. I put it in. There's a photo transistor above that, below that sense its presence. It will turn slow. The press station, it will, what the Right, now let's take a look at the hardware. It's Fisher Technic. It's Fisher Technic. It's known as pneumatic process plant 24 volt, right? And the manuals are, it's hard to find actually. I couldn't find it on internet. So now let's try with the operation of the plant with the training kit. So at first I would like to introduce something called, I call it initialization, where it resets the plant to an initial state, where you can check either if the plant is working or not, all of the compartments and the sensors and everything inside. The initialization process won't run if one of the sensors is failing, or if one of the push buttons, it's over here, and the buttons over here. The whole thing won't run if there's an object inside obstructing the push button, pressing the push button, or if something blocking the photo transistors. Right, for such, I restart it again. I put my hand over here, it will stop until I remove my hand. So to make sure that the plant is actually like, it's ready, there's nothing inside, it's clear of objects. So now I try to fit one of my object in. I call it magazine. There's a sensor, push it in. The turntable will turn until the press station, and then it will press once, yes. Then we keep turning to the swap station and it will move out. Yes, like this. So I take it out. So now right, I try to fit a few inside, right? So I put 1, 2, I put 3, I put 4. So I stack up 4 items inside. See, the process plant, it's working. Before that, the whole process is like continuous, so it won't stop or anything. The process won't stop. It will straight feed out onto out the plant, which means that the conveyor belt will keep moving, so that my cylinder will actually move out the system, the entire system. There will be an off delay on the conveyor belt, but now we are doing some changes to suit industrial standards, where we try to isolate all the stations, right? By isolating means that one station, customer can choose to turn off that station, where it doesn't really depend on other stations, the output of other stations, right? So let's say that my photo transistor now is blocked, so the entire system is stopped. It's because my conveyor belt is not available. There's something blocking. So there's one item over here which is stopped, and waiting for the output to be removed. So this one is finished pressing. The cylinder over here is finished pressing, and then after that there is another cylinder waiting for input again, of course. Then if I remove this one, the plant process will actually continue. There's still some bugs inside. I changed the program before that. Maybe there's still some bugs I need to troubleshoot later. So I still remove it. Yeah, it's working. Oh, okay. Maybe the problem, I changed some timing of the plant actually, so maybe I changed it just now. But later on we try again. I make some amendments, see if it's working again or not. But the presentation is over. Actually, before that, before I make the changes, it's still okay. Now I'm just experimenting with some new ways and some techniques to come out with different programs. Alright, so that's it first for the hardware. Now we proceed to SCADA, which I spent a lot of fucking time. Back here, we just now I forget to save the program, so I have to like I have to reprogram the thing again. Wait, let me save. Fuck this shit. Okay, so now I made my previous amendments. I restore some of my latest programming. I think it should work fine now. I just stack everything up. Yes. Same thing, I take this off, continue running, something like that, to stop and wait for the item to be removed. Because the plants are independent, the parts, like I mentioned just now. So you finish pressing, you will stop, you will wait, and then I remove it, it will start working again. Yeah, something like that. So I remove it again, you will continue going, of course. Right, so wait, what the right now, so what you're looking at right manager from up here, you can see this is one of my projects lah, the variations of projects. I have different variations. I change some styles, I want to try new styles, and then create a new project of the same project. That's how I like to do it. So this is the SIMATIC manager, where you can see I do my programming. This is where I do my programmings and some other hardware configurations and settings, right? Then sometimes this software is also known as step 7. So step 7 program is integrated into SIMATIC manager. There's the other type of SIMATIC programming interface, which is called TIA portal, which is, what do you call it, totally integrated automation portal, which includes WinCC and SIMATIC manager all together. So it becomes a more integrated software and system. It's more user friendly, of course, but that's I think that's for S7 SIMATIC S7-400, that series, the other series. So this is what you're looking right now is SIMATIC manager, and the other one is WinCC. They will go through it now. And then so this is basically, this is my programming variable table, and we have symbol table. This is called a symbol table, where it's like an equivalent to Arduino programming, where we clarify something, but the difference is, instead of, if we don't use symbol table, it's also fine. We can still assign to a memory, but symbol table exists so that we can give that memory or particular byte or word a name. That's it. Then the flags over here are usually I use to transport my symbol table to text. where tags are usually an assignment name to the input and output or the memory bit, the ports log. Basically the name that I have given to my ports or my memories, things like that. So the other one I have here, it's variable table. Yes, variable table. From variable table, it's different. It's a bit different from symbol table. From symbol table, I just declare, I give a name, right? So but for variable table, you can actually control some of the variables, right? So let's say I go to monitor, and you can see some of the state of the ports I have. Some M is memory, I is input, and Q is output. They usually don't use 0. It's some term passed by Germany, so they're using Q. I think most industrial use Q as well. I saw some of the stuff. C, it means counter, MW it's memory word, MD is double word, T is timer. That's it. Yes, and you see some of the, I can override some of the memories. Let's say acknowledge, it's one of the bits I use. I can change it to true, and I can change it to false, right? Acknowledge is a bit where I acknowledge I have a alarm, or there's a fault in a system, there's an error where I used it. Then some of the ports that I actually cannot be overwritten, such as, I think it's this one, always on, I think it's this one, where I keep magazine C, PPT, I think this one, yeah, my photo transistor. So yeah, I cannot assign it. Even I try to assign it, but I can't assign it. I can't assign it because it's directly fitting from the plant itself. But of course I can try to assign it, but usually it will stay that way until it's been overwritten. Okay, done. So this is basically the difference between two tables. Then after that, in the programming itself, you see here, if you see here, there's a few OBs, right? The OBs are called organization blocks, and my main user program, which how my simulation runs, is stored in OB1, which is where I store my main user program, right? And other OBs are actually, what do you call it? Those are situationals. Of course, my whole program can run with just a single OB, which is OB1, but others, OB 82, 83, 84, all this I can add in to prevent other stuffs. Not to say prevent, but I give the PLC a way to handle an error, right? For example, my OB100 is warm restart. So it means that whenever I warm restart before running my OB1, my OB100 will run first. So it means that maybe I want to set up my some of the ports, I want to set up some of the memories, I want to do some initial configurations on the software side, PLC side. I can always use 100 or OB100. And then OB83, it's insert remove module interrupt. So it's like on how the PLC will react when I actually remove one of the modules. Maybe I'll stop the program, maybe I will set some of the bit to stop it or stop the process, or I can just go back to initialization, something like that, right? And FC, it's a function. FC is function, just a function, yeah. And there's the other one we call FB, which is FD function, FB function block. FC is just function. There are different things. Usually in programming, from my senior engineers experience, where they usually like to isolate different programs into different parts of programs into different functions, so it's easier to see. But for me, I don't really like it, so I like throwing everything into OB1. And then maybe functions, because I have to open a few functions at a time, and Windows is kind of annoying. So now I'm just doing a small project. I opt to throw everything into OB1. So in OB1, I open it. You can see this is my programming, of course. And this is STL. This is known as STL, statement list, where it's kind of it's like assembly language where we learn in my university. So some of the logic I use. This is my first network: initialization, input phase, processing phase, output phase, object counting, tracking, delivering, fault detection, handling. I actually try to use the network as my function blocks lah, but it doesn't work that way. So yeah. So I trial and error monitoring. This is what I've been doing just now, right? So there's actually in SIMATIC there are 3 different on the basic package lah. There are some extensions on step 7 as well and TIA portal. But now we have a few programming languages, right? So I insert a new network. Maybe KK. Okay, let's say I put initialization, right? Then if I have initialization, then I will set my acknowledge bit. After I set my acknowledge bit, you actually hear the sound, the siren coming from my PC lah, right? So this is STL. I can change it to, where's the changing? Yes, I can change it here. So this is FBD, a function block diagram. And then the other one is ladder logic. The difference between all this programming is where the representation of data, right? So for FBD, you can see like a process flow on how your program is going to work. And of course, in real time monitoring, you actually see. I'll turn on the monitor. Okay, no, never mind. Upload it. I monitor it. You can see the representation of data, right? So I open it. You will see green where the bit starts. Then I see this. One of the SCADA we're going through later. I will go into later. Let's go back to and my OP. Yes. Okay, so this is one of it, and the other one is ladder logic. Yeah, I can change it to oh, it doesn't allow me to change, but never mind. Some of it can change, some of it cannot change. So it's like it's kind of, just yes, and go back to the same thing. Okay, so I go to STL. Okay, STL again. You can type my stuff. Initialization, and then reset VCK, right? Then we also can convert to ladder logic. This is called ladder logic, where you can see the binary representation of the data. So this is called a coil. This is called an N coil. When I started, I don't really understand, And then I switch between these 3. I switch between these 3. I switch between these 3 to see the different representation, and then I finally realized that, oh yeah, this one I learned in university is supposed to be easy. Learn it like something I finally realized that I learned in university, and I can apply in my internship. Yeah, then I chose this one. But you can change between these 3 basically, but like just now I couldn't really change it. Some of it you couldn't change, and the things you do in FBD your function block diagram and your ladder logic, those things that can be achieved by these two might not be achieved by using your STL. STL is more versatile, more flexible, where it's more towards machine language. You can have more complicated functions compared to the other two. I'm going to delete this. Delete this. Yes, now I try. Just now I change from, I think, put face up. The input initialization. Oh yeah, this one. Initialization. Turn it to slow. 100 millisecond. Free timer. No, that's not this. I increase this duration and try if it works. I was playing with the duration just now. Right, so we are back. Right, so this is basically the general introduction for you on my programming. Some part of it, press slash. Yes, just now the problem with my programming was at, where is it here? Virtual fault detection and handling. Yes, so you can see actually this part, and is it this one? Oh no, not this one. Yeah, this one. Actually, I just added this instruction clear, where it clears out the RLO. When I monitor it, you can see there's nothing over here, right? You can see there's nothing over here, but when I put the three cylinders inside, you'll see some. Yeah, you see all of it, it's 1. So it means that my press slash will be. Yes, it was supposed to be run just now because my timer has finished running. Here's my timer 21. Oh, it's not here, never mind. It ran just now, actually. But never mind. Rewind it. Okay, now I clear everything. Right, we move to SCADA, right? So now if I've done with this shit, yeah, here's the SCADA, here's the homepage. It's just a introduction information regarding my project. And then I log out. We can this is part of the project where we have a user login page. We put in all the credentials. Just want to log in for you to tell you guys that I am the admin. So yeah, this is the home page. You can see the SIPs and everything. Yeah, and then the next one is plan overview. So the plan overview is something like an introduction, explanation on the parts of the plan. You know, this is A, B, C, D, which connects to, where is it? Here to here. There will be a tube actually. This is the compressor tube, where when compressor is on, and ABCD will be controlling the output of each place lah. That's how the plant works. And then there will be signal ports, mechanical outputs, all this as an introduction, plant hardware, introduction to maybe an operator. And I've added this one, plant manual, where all these, some of the things I take it from the plant itself. Something I take it online, something I can take picture of it. So now this is part of the plant. It says input, output, through state, block, not block, everything, additional information regarding the plant. And then through plant processes on how the basic operations of the plant, right? Same thing, insert, turn, and push out, and everything. Yeah, that's it. Basically, that's it. That's easy. So the next one is system structure and configuration. Yes, this is the main part. So my PC right now is the operator station, right? With my WinCC and everything. WinCC, okay, this whole thing is known as WinCC runtime, where it's like a real-time monitoring where I can pull data, which you will see in this tab later, right? So my PC right now is operator station, and Ethernet switch is where I connect to. This is my redundant system, my H system. S7-400, right? The green one, it's known as Profinet. It's a type of industrial Profinet with different protocols, right? The protocols I can set, maybe I can set Modbus or TCP/IP. This kind of protocols I can set within my PC itself from operator station. In short, they call it OS also, right? After switch it, it goes to redundant system. That's how my computer communicates with my system, right? Then you can see the orange here, which we mentioned it already just now. It's fiber optic cable, and then Profibus towards my link, the entire thing called Y link, and then goes to my DPIOs, right? So when we come out from H system, we have to go to Y coupler before we go into ET200S and ET200M. It's because that during the whole control, the one of the PLCs will assume master, and to control which output or which PLC it should listen to, that's where Y coupler comes in. It will tell the ET200S and ET200M from which PLC to listen to. There'll be two different PLCs, and these two different PLCs have two different IP addresses as well. That's why link and Y coupler, the entire Y link is so important. And ET200S and ET200M cannot be connected directly to S7-400 H system, because the system won't know which PLC to listen to. That's why two of it, S7-400 H system, will be connecting to two Y links, and this whole thing is called Y link link and then Y coupler, and then it only goes up into my plant. Alright, and the title suggested that the entire system is supposed to be IIoT ready, industrial Internet of Things ready, and all of this is represented by this part. I have my operator station where I pull raw data from my PLC from here connected, and then I go to cloud processing. To process cloud processing, actually I need an additional module, but from now I don't have the module yet, so we just leave it out that part. And then connected to OPC client. OPC actually stands for open communication, open port communication. You see? Open platform communications, yes. It's like a standard as well to allow different communication mediums to connect with each other. And that's where I can have a set up a website where I can pull my data from the processed data, the calculations and everything from my cloud, and then straight goes to my website, right? So this dotted line, it seems like I can have some controls over my plant and monitoring as well, right? By control means that from the output ports, I might not control I might not have direct access to my input and output ports, but I can always assign another bit or another memory that I can control, and by manipulating my bit, I can maybe rerun my logic so that my plant could work differently. That's why. And last but not least, we have real-time monitoring. Right, so now everything is like this, right? So I have restarted the whole plant. So I push the push button off. So you can observe that the whole thing will go into red. You won't hear the sound of the compressor because everything is off. It's like a main switch basically. So system on off is off. This fucker, this thing will be blinking, right? I acknowledge my fault. This thing is acknowledged. I push it back on, the whole thing will go back into initialization, and there will be representations on the graphics on what's the current state of my project right now, right? So let's say right now I put my finger over the phototransistor, which is over here. So you will assume that the thing is blocked, right? Turntable timer and belt timer is one of a few of my fault handling control, fault monitoring. So let's say that now I put my one of the cylinder inside. Now I put a cylinder in. You can see it's over here. It's pushing, it's turning. It's at the press state. It's approaching the press station. Right? Pressing starts. It's one of the bugs I have to settle later during initialization state. Maybe I've settled it, but maybe I didn't save it. I don't know. It's quite late. It's in. It's turning. Press nigga. Yes, yeah. Here's come the the animation where it press once lah, right? You can see the number here. Press number is 1. Means that the system will press once, and then its output it's swap over here, and then you can see the representation, right? Then if I stack maybe 4 cylinders inside, you see the press number by default here, right? So in press number by default, it means that for each increment of input number, I actually increase my press number. So it means that the first item will be pressed press once, the second item will be pressed twice, the third item will be pressed 4 times, right? It's one of the default operation where I started programming. Actually, it's just press once, right? Then to give myself some challenge, I put some incremental looping inside to try out different stuffs lah, basically. Then to change it, actually I can put it to a user defined, right? I can go to here, press number control, I activate it, I put 4, okay, and comes back here. You can see user defined. It has changed lah, basically. And then the next item will be pressed only 4 times, but my default number will still keep count of how much I have pressed. It will still be incremented as well. You won't see it over here, but yeah, if you hover over all these things, you actually I put extra effort into like labeling to know some, something like that. Right. So some of the things of course start stop, right? Now I try putting one thing inside. I'm going to simulate a fault, right? I push it in. Now it's supposed to be here. Now I take the cylinder out. It's supposed to detect cylinder over here. Press station, but it didn't. So turntable timer counts down. It reaches 0, means that I have reached a fault. The timer will be the thing will pop up lah, acknowledge. The siren will start to, it's annoying. Then on the fourth part, where how I use it is where when the turntable is turning, this is the turntable. When it is turning, I will start my fault monitoring. When it stops, I will stop my fault monitoring. So as long as my countdown doesn't reach 0, I'm actually making sure that I'm not there's no problem in the system. So I'm going to wait, shit. I'll reset it again. So the other thing requested by the host community supervisor is that I can resume my system whenever I wanted to if there's a fault. Right now I take it out, it's pressed, I push it out, I take it out. So it will be counting down here, turntable will keep turning. I assume my items was supposed to be here, right? So that's why there's a representation over here. Now my turntable is misaligned, it's not in the correct position to stop. Okay, now I put back my cylinder on the turntable and then I resume the system again. And it will start without any fault. You go back to the system again lah. Like some of the industrial control, there's a fault that happens, then I rectify the mistake, I rectify the error, and then the plant can start working again. It's part of the challenges given by host company supervisor. Okay, now basically that's like this is the SCADA we've been talking about, the supervisory control and data acquisition. Go to settings. This is part of some of the additional settings, and this part was actually only exclusive to administrators. So let's say I'm administrator. Actually make let's go into an operator account and see. Right, so I go back to real-time monitoring and then go to settings. I won't be allowed to use it, of course. It's been disabled. Login again. Yeah, I'm in. So I'm back here again. That's it. This is same as initialization, just that it's one is hardware mode and one is software mode. Start, stop. Oh yeah, just now when the whole system go to stop, right, you can see something turntable calibrated. Okay, let's say I start again, I put one cylinder in, it goes run, I take out the cylinder. Now you will see the turntable timer start to count down. That timer is something I use later on. It's just an extra precaution. You can see